Electric circuits. How to identify the resistance that are in series and resistance that are in parallel. First, we need to know that the current that comes out from the battery is the total current. So when the total current flows through the resistance, that resistance is going to be in series. So if we look at resistor 1, the current that will flow through it is a total current. Since the current that comes from the battery, it goes straight to resistor 1. So but once the current gets to a junction, the current is going to split. It's going to split to be current 2 that will switch on resistor 2 and current 3 that will switch on resistor 3. But the sum of current 3 and current 2 will be the total current. So if we look at resistor 2 and resistor 3, the current that will flow through them is not a total current. So therefore, resistor 2 and 3 are in parallel. But once the current passes through resistor 2 and 3, they are going to meet again at this junction here, and they are going to make up the total current. So the current that will flow in resistor 4 is going to be the total current. So therefore, resistor 4 is in series. And that will happen again and again. What we have learned is that to identify resistors that are in series, the total current needs to pass through them. But if the current that is passing through the resistance is not a total current, therefore those resistors are in parallel. So how do you calculate the sum of resistance that are in series? To calculate the sum of resistance that are in series, you add the resistance. So the equation for resistance that are in series is sum of the resistance. Let's say, for example, we want to get the sum of resistance that are in series. We know resistor 1 and resistor 4 are in series since the total current is passing through them. So we are going to say the sum of resistance that are in series is resistor 1, which is 1 ohm, plus resistor 2, which is 4 ohms. So therefore, the sum of resistance in series is 5 ohms. But now if we want to identify the sum of resistance that are in parallel, we are going to use the following equation. 1 over R parallel is equal 1 over resistor 1 plus 1 over resistor 2. So first we need to identify which resistance are in parallel. We know that resistor 2 and resistor 3 are in parallel since the current that is flowing through them is not a total current. So we are going to substitute them and get the sum of the resistance that are in parallel. So you're going to say 1 over R parallel is equal 1 over the first resistance that is in parallel is 2 ohms. And the second resistance is 3 ohms. So now to get the 1 over R parallel, we're going to say in our calculator 1 over 2 plus 1 over 3. And that will give us 5 over 6. But now this value is not the sum of resistance that are in parallel because we have now a reciprocal of the resistance that are in parallel. To get the resistance that are in parallel, you are going to change now your fraction. The bottom will come to top and the top will come to bottom. So therefore, the R parallel is 6 over 5 ohms. If the question asks you to calculate the total resistance of the circuit, the total resistance of the circuit is the sum of resistance that are in series plus the sum of the resistance that are in parallel. So we have already calculated the sum of series and the sum of parallel. So now we can get the total resistance in a circuit. We will say now the total resistance is equal to the resistance in series, which is 5 ohms, plus the resistance that are in parallel, which is 6/5. So therefore, the total resistance is going to be equivalent to 5 plus 6/5, which is the same thing as 31/5 ohms. That is all for this video.